Ramani has completed the Bachelor of Engineering in Mechanical from the MS University, Baroda in the year 2000 and the Master of Engineering in Jet Propulsion and Gas Turbine from the same university in the year 2002. He completed his Doctor of Philosophy in the Solar Thermal System from Indian Institute of Technology, Roorkee in the year 2008. Professor B.M. Ramani has joined the A.D. Patel Institute of Technology, New Vallabh Vidyanagar, Gujarat in the year 2002 and served in various academic positions for 9 long years. Professor B.M. Ramani has joined the SLT Institute of Engineering and Technology, Rajkot in the year 2011 and currently holding a position of the principal in the institute. Professor Ramani has an academic experience of 21 years along with 1 year industrial experience. His area of specialization and research is solar thermal heat transfer. Professor Ramani has published 30 research papers in national and international journals and conferences, and he has 2 patents on his name. Professor Ramani has guided 8 students for the PhD degree. He has organized more than 4 short-term courses, workshops, conferences, seminars, and also delivered a number of expert lectures. He is involved in various consultancy and research projects. It is an honor and privilege for us that we have Professor Ramani with us today. Today, he is going to deliver an expert lecture on solar energy technology, the way towards sustainability. His deliberation and expertise on this topic will surely benefit all of us. I now kindly invite Professor Ramani sir for the expert session. Professor Ramani sir.
Thank you very much, Coordinator, Professor, for a brief introduction. And in fact, it is my pleasure to be a part of this particular faculty development program. Before I start, let me assure my voice is clear and audible.
Ramani sir, you are not audible.
My voice is not coming?
Kindly unmute.
No, sir, you are audible, sir.
You are not able to hear us.
Completely audible.
Audible.
For myself.
And I would request all other participants to remain muted.
Yes, of course.
Before I start, let me assure my voice
Sir,
is
you are
clear.
still not audible.
Yes, sir, you are audible, sir.
Someone says audible.
Yes, I can hear you. I can hear voice.
Voice is coming?
Yes, sir.
Yes, sir, it's coming.
Yes, sir.
Yes, sir.
Hello?
Yes, sir. It is audible.
Totally clear.
Yes,
I
sir.
have received message. So with permission of coordinator, let me start the discussion.
Yes, sir. Yes, sir, you may.
Yes. Coordinator, can you assure?
Yes, sir.
Is there anybody from the GSC Bhuj who is coordinating the program? Professor Modi?
Yes, sir, you may convey the problem. Sir, this is Brijesh Gotawala from GEC Bhuj.
I don't know whether my voice is reaching to them or not.
Yes, sir. Yes, sir, it is audible. Ramani, sir.
So
Let me have a
your
pause.
voice is audible.
Just a minute.
Voice is clear, sir.
So first of all, good morning to all of you. And I must congratulate team JC Bhuj for planning and organizing this wonderful faculty development program on the topic which is very needed, not only for us but for the whole world. Professor Suthar, Professor Rathod, Professor Modi, Professor Sorathia, and the whole team of GEC. I am thankful to them for giving me the platform and giving the opportunity to share few things related to the recent advancement on the solar technology. In fact, I am sure that this particular discussion is going to be worth, and at the end of the FDP you will be having a lot of ideas, lot of thoughts you will carry on, and which will help you to pursue further your career in the field of the renewable energy, and you will continue the momentum and the pace of the discussion even at the end of the FDP. So with this particular line, let me start the presentation. I am sharing my screen.
No, not visible your screen.
Sir, your screen is visible.
So I hope my screen is visible to all.
Yes, sir.
Yes, sir, visible.
Screen is visible?
Yes, sir.
Yes, sir.
Yes, sir, the screen is visible.
Yes, sir, your screen is visible.
Can anyone assure?
Yes, sir.
Screen is visible
Visible.
or not?
Yes, sir. Yes, sir.
Visible, sir. Please, sir, continue.
Hello?
Yes, sir, visible, sir.
Hello?
Sir, you are muted. Kindly unmute.
Yes, 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 yes. Okay. Now it is audible? Okay. Thank you. There are certain advantages of online session and there are certain disadvantages of online session. Anyway, technology helps in many ways. So finally, I have received assurity that my voice is also audible and screen is visible. So let me start with the first session. The topic of the session, that is solar energy technology, the way towards the sustainability. We are going to discuss two aspects. Number one, solar energy and the available technology, and why we call it as a sustainability. On these two issues, we will be having a detailed discussion. The flow of presentation will be like this. Introduction. We will briefly introduce and discuss why do we need the solar energy? What are the drawbacks of the non-renewable energy sources? We will have a brief introduction, then present need, solar energy technology, thermal collectors, development, particularly in the air heating, water heating collectors, the available technologies, barriers that we are having, what is the way ahead. We'll also briefly discuss recent advancement, recent trends, and latest development in the field of solar energy technology. And if time permits, 547 formula of the research, and we will try to conclude the session. This is going to be the flow of presentation. From many years, we have a common complaint that there is a shortage of energy. Energy is not available. But this is not true. let me tell you very frankly. Suppose if somebody asked, if government announced that petrol will not be available for next 2 days, what will be our priority of the day? Our priority of the day will be to ensure that we store at least 2 days fuel so that next 2 days there will not be any issue. I hope my voice is coming.
Yes, sir. Audible.
Chat box, I am getting message. Okay, there is some disturbance, I think.
Yeah, voice is clear, sir.
So if fuel is not available for 2 days, our priority will to store the fuel for at least 2 days. We line in the petrol pump and ensure that we should have a fuel for 2 days. So in fact, on that side, if we look, then we feel that there is a really shortage of energy. Energy is not available. We have used energy, particularly from the conventional sources of energy, very, very extensively. Today, petrol is available very easily, diesel is available very easily, conventional fuels are available very easily. But we don't know that in future, maybe our generation, next generation, for those people, this sort of energy will be available or not available. That is a big question. Then what to do? So, it is a responsibility of us jointly for all of us to ensure that the future generation also get the required quantity of energy. That is the first aspect. Second aspect, so far from almost last 1 century, from last 100 years, we have used conventional sources of energy very extensively, one-sided, ignoring the second side. We have not thought of the consequences of large scale of conventional use of energy. And the result is in front of us. The whole world is facing the many problems which is because of the conventional sources of energy. So nowadays we are listening a word called sustainability. Energy sustainability is extensively discussed in the scientific and political community. You must be knowing about the sustainable approach from last few years, from last 1 decade, from last 10 years. We have introduced the sustainable approach. Until now, there have been two different approaches on the matter. One, consider an increase in electricity consumption essential for the economical development and social progress of the countries. So far, only electrical consumption was in the target. How any country can produce more electricity and same way consumption, ignoring the second part. Whereas other, which is more important, are more concerned about keeping carbon consumption within certain limits. That is the second side. Now we are thinking about the carbon contains, carbon emission, carbon footprints. These are the new words which we are listening. So we need to investigate, we need to find out the new sources of energy which are environmental friendly, clean, and do not emit carbon dioxide. And that is what we call it as a sustainable approach. So the definition of sustainability is not unanimous among the scientific community. In the literature, it is associated with different concept depending on the point of view studies. So far, we only know the payback period, payback time. But along with the payback time of the system, there are certain things, probably you must be knowing that there is a environment load ratio, energy yield ratio, energy sustainable index, environmental load ratio. These are the words now we are putting into the picture, ensuring the second side of the energy production. In conclusion, it is not only the energy production, but the second part that is also very important, that energy production, energy generation with minimum carbon emits or without disturbing the environment, without disturbing the nature, that is very important. Hello? Hello? Sir, screen क्यों ले लिया?
Yes, sir. Sir, we are audible. Sir, we can hear your voice.
I don't know why the screen is repeatedly disappearing. So what is the present need? You can see on the screen the global warming from last so many years. We are facing the problem of global warming. Every year the temperature of Earth increases. And that's why this is a concern for the whole world. Even if there is a rise in temperature, maybe 1.5 degree, 2 degree, it is going to create a big problem for the whole world. And that's why you must be knowing about the recent meeting which was held at international level. The prime agenda for the discussion was to keep the temperature rise less than 1.5 degrees centigrade and probably 2 degrees centigrade. So the whole world is worried about this issue, that is global warming. Second thing, that second about 30% transportation and maybe 20% industrial and roughly 10% residential. This portion share of energy production, you can see renewable 8 to 10%, but nowadays from last 5 years it has increased and probably now it is almost 15 to 20%. Today we are talking about the thermal power station based on coal. Most of the thermal power stations which are operating as a fuel, either coal or maybe diesel, naphtha, liquid fuels, but all conventional sources of energy. But maybe after some time, if I'm not wrong, maybe after 10 years, you will find a solar plant generating electricity like the coal. So this picture is going to change and the responsibility is with all of us. You can see in this particular slide, this very useful information I have taken to sensitize all of us, to aware you about the development. I had come across a very good review paper, and that review paper has a very systematically reviewed the most of the research work that has been carried out in the field of renewable energy, in the sustainable, the solar energy, in most of the green technology field. And it has pointed out the number of investigators from different countries. You can see here in the America, it is almost 2,107 investigators have contributed, particularly in the field of renewable energy. Same way, China 919. India is also, we are good, we are happy that we are also not lagging in this particular field, and we have contributed almost more than 700 very nicely you can say tabulated, compiled research work in the field of renewable energy, particularly leading to the success. This shows the whole world is worried about this particular aspects, and that's why the most of the research and development activities has been diverted from the conventional energy sources to the renewable energy sources. This you can see the share in percentage of various investigators, various researchers who are working in this particular field. We are also not far, as I pointed out, almost contributing 6 to 7% worldwide. In the lower figure, you can also see the domain in which the work is carried out. And the larger portion, that is the sustainability. The other areas are also indicated. You can see renewable energy, solar energy, energy, photovoltaic development, exergy, life cycle assessment, energy analysis. But out of all these domains, the key domains, that is renewable energy and sustainability, which indicates very clearly the whole world is worried about this particular aspects, and we should do something so that we can develop or we can generate energy sources and with sustainability. Now, as we know, there are variety of renewable energy sources are available, and each source of renewable energy is having its own advantages, own limitations. Like we know, we have a solar energy, we have a wind energy, we have a geothermal energy, we have a tidal energy. Even other resources are available. Then why solar energy? So there are three key features which I would like to highlight about the solar energy, and probably we must be knowing about this. First, it is the most promising renewable source of energy. Most promising. It is available today. It was available in the past, and I'm sure that it will be available in the future as well. It is not going to over. So most promising sources of energy. As I told, you might have heard about a common complaint, there is a scarcity of energy, energy is not available. In certain rural areas, energy is not available, probably you might have heard, but that is not correct. In fact, energy is available, but we do not have appropriate concept, appropriate technology, appropriate methods, means to harvest this particular energy. So solar energy is the most promising renewable source of energy from available renewable energy sources. Second, it is an essentially inexhaustible source of energy. So it is not going to over. Every conventional energy sources is having the biggest limitations, that once we use certain quantity from that, then that resources is getting reduced. That quantity is getting reduced once we use. Different from that, solar energy is called an inexhaustible source of energy. That means in whatever way, in whatever quantity you use it, it is not going to over. I will not be wrong if I say the energy available from the sun in a day in the whole world, that is more than the energy consumed by the whole world. So you can understand the plenty of energy is available from the sun, but we need to harvest by suitable means. So it is essentially an inexhaustible source of energy. Third, it has potential to meet a significant portion of the nation's future energy needs because of its quantitative abundances. As I already pointed out, it is not going to over. If we have an appropriate technology, probably, then we can generate more energy than we consume per day, per month, per year, whatever. So plenty of energy is available in front of us. Energy is available from the sun, but we need to find out the appropriate technology. And the most important, fourth one, it is clean and environmental friendly source of energy. We are not going to pollute environment. We are not going to emit carbon dioxide and other polluting emittents. Once it is ensured solar energy. So it is clean and environmental friendly source of energy. And that's why at the world level, the research and development has been concentrated in the field of solar energy. Of course, there are certain limitations, and probably we are working on those limitations, and the substantial amount of research and development has been already carried out and come up with the possible solutions. Like it is a diluted source of energy, so we are working continuously with the energy storage, so that even the sun energy is not available, we can be in a position to utilize the solar based energy system. So that availability varies every second, every moment, every hour, every day. So that is a challenge, and we are working on that. We jointly working on that. It needs storage system. That was in fact old, but nowadays even without storage, grid connected systems are also available. But still, alone solar stand system, probably it will be difficult in the present context to visualize, to use it, but definitely it needs storage system. So these are the challenges, these are the limitations, and on those limitations the whole world is working, and I'm sure that in future these limitations will be over and the contribution of the solar energy is going to increase. Let me show you a video which will speak about the importance of solar energy. Is it getting played?
No, sir. No play.
Okay, I think I will skip. I'm not getting voice from anyone. I don't know where is the problem.
Sir, the screen is showing blank here.
Can anyone check me that whether you are in a position
Yep.
to watch this video? Otherwise, I
So,
will.
so we can hear your voice, but the screen is it is showing blank only. Blank screen is showing here.
Sir, PPT is
visible, but the video is black.
Video not playing, sir. Okay, I will skip. Don't worry. Thank you.
Yes, now it is visible, sir.
So when we are talking about solar energy technology, there are 3 steps which are involved. Number 1, the collection of solar radiation. We call it as a collecting unit. Second, we call it as a converting unit, energy conversion, wherein the radiation energy is converted into the useful form. And third, available technique. These 3 steps are involved in the solar energy technology. First step, collection. So we have 2 types of the system. The flat system, that means without concentration, the radiation fall on the flat collectors, will absorb by the absorber plate will be heated, and the heat will be transferred to the working substance depending on the type of the system. If rays are concentrated, we call it as a concentrator. We use the concentrator. The solar radiations are pointed. We know we have used lenses, very layman's approach. We keep a lens in front of the solar rays, so rays will be concentrated, and at a point, focal point, we can generate a lot of heat, a lot of temperature. And that is what the latest technology is used. We concentrate the solar radiation so that maximum temperature can be generated. So the system, either flat collector or the system with concentrating collectors. About conversion things, we have 4 technology. First, photovoltaic, very widely used, commercialized, and nowadays on every home, every rooftop, you will find this photovoltaic cells, which directly converts solar radiation, light energy into the electricity by photosynthesis effect. Second, thermoelectric effect. That also probably you must be knowing. Photoelectro cell and heat engine. On the same side, there are available techniques. Photovoltaic panel, concentrating photovoltaic system. These are the widely used systems, and nowadays the most of the technology have been advanced and has reached to the next level from the demonstration to the application part. Solar cell, solar power generation mechanisms. So with these 3 steps, we can harness and we can utilize solar energy. As I already emphasized, when we are talking about solar energy, basically there are all technology can be combined into 2 categories broadly. One, we call it as a direct technology, and second, we call it as an indirect technology. Direct technology means the solar radiations are directly converted into the electricity, photovoltaic. There is no moving part, nothing. Very simple. The conversion of light into electricity directly. And second, we call it as an indirect technology. That means we are converting radiations into the heat energy, and that heat energy can be utilized for different purposes like heating, maybe for power generation, maybe for industrial process heat, maybe textile requirement, whatever. So direct system and indirect system. And I think in the FDP, there are different sessions related to the solar energy, related to the renewable energy has been already planned. So we'll not discuss photovoltaic part, but we'll be discussing in detail about the thermal conversion part, thermal technology. So when we are talking about thermal collectors, basically there are two types of the collectors. As we know, collector is a very important part of the whole solar energy system, because it collects and it converts the radiation energy into the useful form, and that's why we call it as the heart of the system. Solar collector is considered as a heart of the system, whether it is flat collector or it is concentrating collector, no matters. But for any solar energy system, solar collector is considered as a heart of the system. So there are two types of the collectors which are normally available in the market or normally we use. Number one, we call it as a stationary collector. In the stationary collector, you will have three categories. Number one, flat plate collectors. As I already told, we call it as a FPC collector. Second, we call it as a compound parabolic collector, CPC collector, wherein there is a compound parabolic collectors is there, rays are concentrated, and third, evacuated tube collectors. The stationary means they are mounted at a fixed space, they cannot move. This we call it as a stationary collectors. Second category we call it as a concentrating collectors. We know from last 10-15 years, by available technology, by tracking mechanism, we need to ensure that the maximum radiation constantly fall on the collector. And as we know, there is a continuous movement of the sun. So we need to track the collector so that for the maximum time collectors get beam radiation, direct radiation for the larger and wider benefits. So we concentrate the collectors and we provide the tracking mechanism. So the collectors falling in these categories are parabolic trough collectors, commercially we call it as a PTC, where there is a collector having a shape of parabola, and at the center there will be a receiver tube. So rays are concentrated. The parabolic trough can be provided tracking mechanism, and the heat energy can be utilized. We are going to discuss in the detail. So first one is PTC. Second, the Fresnel reflector based collectors, we call it as a linear Fresnel reflector collectors, LFR. Third, disc type reflector, parabolic disc reflector, PDR. And fourth, heliostic field collector, or we call it as a central receiver system. So these are the types of collectors which are available, which are normally used to harness the solar energy. You can see here the brief comparison. Will not go in the detail. Stationary collector is having its own limitations. It can be a flat one, it can be a collector with the concentration ratio also, concentrator you can say. But in the last column you can see the range of the temperature. So as I told you, in order to achieve the higher temperature, it is becoming essential to provide the tracking mechanism. So you will have two types of collectors, single axis tracking collectors, mechanism having a tracking on the single axis, and the collector having two axis tracking mechanisms. And in order to achieve higher temperature, it is very essential that we can provide the tracking mechanism. Now if we categorize the available solar thermal technology, they can be categorized in the three main groups. Number one, we call it as a low temperature technology. Second, medium temperature technology, and third, high temperature technology. The first, low temperature technology that are commercially available, it is widely used. Lot of research work has already been carried out, and commercially it is available. We use normally for air and water heating. We must be knowing about the air heating collectors and water heating collectors, wherein the temperature heating is limited maybe up to 100 degree or 150 degree centigrade. Second, normally in this low temperature we need not to concentrate the solar radiation. Even flat plate collectors will work, and probably tracking mechanism is also not required. For medium temperature, as far as power generation is concerned, we need to concentrate the solar radiation, and as we know, for the power generation we need to boil the working substance at higher pressure, and that's why the concentrators are required. So second technology, we call it as a medium temperature technology, which may be capable of generating a temperature of maybe up to 350-400 degrees centigrade. And third, normally we are using this technology, we call it as a high temperature technology, wherein temperature maybe up to 800 degrees centigrade is also generated. So low temperature based technology, medium temperature based technology, and high temperature based technology. Let us briefly discuss each and available technology in each sector. The first that we know that in terms of or in category of low temperature technology, the widely used collector is flat plate collectors. There are two types of flat plate collectors that we normally use commercially. Number one, we call it as air heating collectors, and second, we call it as water heating collectors. This, in the present slide, you can see the sketch of the flat plate air heating collectors. We know that there is a passage which is formed between the top glass cover and the absorber plate. In that passage, air moves from the one end to another end. Radiation fall on the collector, transferred and received by the normally. India needs to take fresh initiative to assess the latest technology and its feasibility in the Indian context. That is what we need to do. So we have a technology, but I think proper technology made to be viable. And with respect to the international standard, India needs to take a fresh initiative, and I'm sure that we have already taken this fresh initiative, and in coming days, this is going to reach a great milestone. I'm at least happy that today we are standing in front in the renewable energy contribution. So it's a very good thing and positive message, and I hope that collectively all we can pick up to the next level. And probably you must be knowing that the carbon protocols and other that is concentrated on the renewable energy. So our contribution is going to be very, very effective in the future, maybe by 2030. So we Indians are going to play a very, very important and very crucial role. Let me give you a simple example in order to state the importance of this particular solar energy. Nowadays in winter, normally we use electricity water heater in our house. But if we replace this electricity water heater with the solar water heater, it will be a huge saving. 1.5 tons of carbon from a single solar water heater of maybe 100 liters capacity per day, we can stop. 1.5 tons of carbon emission can be stopped by replacing electric water heater with solar water heater. You can see what will be in terms of the whole year, And if we thousand of millions of family, if use solar water heater, what can be advantage? On the same side, there is another advantage. When we use conventional electricity from the sources like petroleum products, coal, we know there is a distribution losses. The coal life, people who are working in the coal mines is also very dangerous. So if we consider all these aspects, then probably at consumer side, if I am consuming, let us say 100 watt, then at producing side it has to be produced at least 125, 130 watt. So that will be a double advantages. So if we replace a small system with a solar energy based system, that will be a huge contribution towards the sustainable development, towards the restoring the nature, and towards our future generation. So I request all of us to think on this particular issue and try to contribute in the field of renewable energy, and collectively we can do better. I think I have taken much time, so we'll skip this particular. Whenever we are doing research, I propose this particular 5 steps: perceive question, formulate hypothesis, test hypothesis, draw conclusion, and report results. We Indians are very expert in reporting part. Without proper concluding, we report the things in terms of publications, and many times our noble work is stolen, our noble thought is stolen. So when we are pursuing the research, I think we should take care of this particular 5 steps. 4 types of research. Natural means 4 things are required in the research. Natural observation. Normally we are trying to copy the things from the other parts, but we must have our own observation, and that has to be a natural observation. Laboratory observation. Normally we adjust the observation, but we stick to the laboratory observation. We should concentrate on the case studies. That means if somebody has worked previously, we should try to look into that particular matter, so that if the limitation of that particular can be considered, and we should involve proper surveys. 7 ethics. The first, human, people, human first, and then research. That we should see. Perfect information. Normally we do not take appropriate time to gather relevant and proper information. Planned debriefing, the permit withdrawal, prepare for undesirable results. Research, always not necessary that every time we get success. We may get failure also. We may not get the result as per the expectation. So that also we should prepare ourselves. Perfect confidential. We should keep the matter confidential. And the permanent relation. After every activity, we should learn the lesson. These are the some photographs you can see. And thank you. Thank you for listening. I hope the session was continuous. However, there is a certain drawback always with the online system. So if sometime if you are getting breaking noise, I'm sorry. Thank you for this particular wonderful session. Now, if you have any question, the platform is open for discussion. In fact, I would be glad to have a discussion. So 5-10 minutes will be there for the discussion. Thank you all. Thank you for joining this. Thank you.
Sir, can you hear me, sir?
I am not getting voice from.
Sir, can you hear me, sir?
Unmute and ask the question.
Sir, can you hear me?
Please,
I'm raising my hand.
one by one, ask the question.
Yes, I'm raising your hand. Can you hear me? Can you hear me?
Yeah.
Can you hear me?
Yeah, you are audible.
Yes, sir. I'm myself Pankaj.
You are audible.
Is it audible now? Is it audible now?
Yeah, audible.
Yeah, okay. Thank you. Myself, Pankaj Bora. I'm assistant professor in Surat Institute of Science and Technology, Surat, Assam. Okay.
I think voice is not coming. Modi sir?
Yes,
Yes,
I
sir.
can hear you, but hello, can you hear me, sir?
Ah,
Let me try to join from
yeah,
other
your
Can you
voice
hear
is
me?
audible.
get.
Can you hear me,
Yeah,
sir?
sir. Your voice is audible.
Yeah, I'm audible.
पंकज बोरा जी आपका आवाज आ रहा है.
Okay, thank you. Myself, Pankaj Bora, assistant professor in JIST Jurhat, Assam. Okay, so sir, I have two questions actually. First of all, I want to know from you that the solar radiation is different for different sites. Okay, for Assam is the radiation is level is another level. In suppose
Hello?
Gujarat, yes, in Gujarat it is in.
Hello?
Can you hear me? I think Ramani sir is not audible.
Now it is audible?
Is it audible, sir?
Yes, you can ask question now.
Yes, sir. So, sir, radiation is different for different locations actually. So, if the efficiency changes, if the radiation will be changed, suppose in Assam, the efficiency of the FPC plates maybe low as the radiation is not like Gujarat in Assam.
Yes.
Yes, sir.
Very good question.
Yes, sir.
In fact, when we are dealing with the solar energy system, there are many parameters on which the performance of solar system depends. And in that, one of the parameter is the climate condition, like
Yes.
ambient temperature, availability of solar radiation. And as you pointed out very correctly, that availability of solar radiation varies. It varies every moment, and availability varies even at a particular place. The intensity of solar radiation available in Gujarat may not be the same as it is available in the Rajasthan.
Yes.
That's why feasibility study and proper assessment is required. Then and then the performance of the system will be a better. Suppose if I have installed a system in the Gujarat, and if same system I feel if it will install in other state, then probably in the same orientation, same system may not work efficiently. And that's why local feasibility study is a very important as far as the performance of solar energy system is concerned. And in fact, that is the point where we failed. So needs a feasibility study, local study. And you are very correct. If we do not consider the local parameter, it may be an environmental parameter, it may be operational parameters, then we may not expect the performance from the system very nicely. Let me give you a very nice example. You might have seen a photovoltaic panel at many places. Okay.
Yes, sir.
Now, the orientation, in fact, it has to vary from location to location. In fact, I have heard people complaining that the solar panel is not giving effective output as of the last month because it was not cleaned properly. In fact, every week the panel has to be cleaned properly. Then and then we can expect the desirable output from the solar panel. So proper assessment, feasibility study is a very essential before installing or before designing and developing a system at any place.
Sir, if does the position will affect the solar thermal plate because in PV panels in photovoltaic PV panels the dust may reduce the efficiency of PV cells. If the thermal system is the dust effect is a factor or not, sir? Does the position on the surface of plate collectors?
What thermal system?
In case of suppose FPC system, okay, in case of flat plate collectors, there is a glazing material in that you shown here. If the dust deposition on these glass plates will reduce the efficiency of the FPC system.
Definitely. Glass, but normally very transparent glass and optical property has to be such that the maximum transmittivity has to ensure. And if we clean properly, then probably the maximum radiations will reach to the absorber, and ultimately then after it will transfer to the working substance if it is solar system. If it is photovoltaic system, then the unnecessary heating of the panel has to be avoided. And if we can provide some mechanism where heat can be removed, then probably we can generate electricity effectively from the panel.
Sir, I'm from basically northeast region. Actually, I'm from Assam right now. I'm from Assam. So in Assam, for FPC collector, as I know, diffuse radiation works more, right, sir? Diffuse radiation is more important in case of FPC collectors, right, sir? If I'm not wrong.
Yes.
Diffuse radiation. So here, most of the environment condition is like that. Most of the time, clouds cover this clouds cover. So due to this, we'll get the diffuse radiation.
Yes. As I told you, solar, when we are working with the solar system, there are many factors which are affecting the performance of the whole system. Suppose if there is a clear sky, then there is no problem. But if there will be a cloud, and if cloud will be for a longer time, then the heated absorber plate will be slightly, its temperature will be lower, and once again it will take a time to achieve its desirable temperature. But that is not in our hand. What we can do, we may keep our installed system in a position so that we ensure the maximum benefit from the solar radiation.
Okay. Thank you, sir.
I mean to say,
sir, I want to ask one question. Avinash Kumar.
Yes.
Excuse me, sir.
Please.
Yeah, Mr. Avinash, ask your question.
Sir, what percentage of solar power currently in the part of electricity in India?
Very good question. As far as renewable energy is concerned, probably it is 15 to 20% contribution as far as India is concerned. And out of this 15 to 20% renewable, mostly 10 to 12% is from solar energy.
Okay.
But nowadays we are thinking of hybridization. Combination of solar and wind. That is what we call it as a hybrid system. Even in case of solar chimney, we have seen. Even in case of photovoltaic system, nowadays electricity will be generated at the same time you will get the heated water. So we are preferring hybrid system in order to get the maximum benefit. And this particular share is going to increase in the future.
Okay, sir. Thank you, sir. Thank you so much.
Any
more
other
questions from any of you? In fact, it is my pleasure to see a large number of audience who are on the same platform from the different part of the India, different from part of the world, and discussing on the same topic. So in fact, it is pleasure to share my views and have a fruitful discussion with all of you. If you have any question, please ask.
Yes, sir. So one more question I have.
Yes, sir.
So if there is any research study that the output power efficiency from a concentrated solar photovoltaic to the concentrated solar thermal technology, if there is any research study is there, so that we can identify that from CPV concentrated solar photovoltaic power, we can get this much of efficiency, and in case of solar thermal, by using the solar thermal technology, we will get this kind of efficiency? Any comparison is research is going on regarding this?
You mean to say comparison of photovoltaic technology and solar thermal technology?
Yes, sir. That means in case of the demand side, that means in case of the output electric power, if you convert the electric power from photovoltaic as well as from solar thermal technology using concentrated solar photovoltaic and concentrated solar thermal technology.
Yes. So both technologies are nowadays, I think, have moved from demonstration to the application part. Photovoltaic panel, we have installed a large amount of panels producing a lot of electricity. At the same time, it is not possible that everywhere the panel or area is available for the installation of panel. So in that particular areas, we need to concentrate the rays and we need to use the appropriate technology, either PTC, parabolic trough collector, or maybe central tower system. As far as performance is concerned, okay, as we know that panel efficiency maybe to 20-25%. Nowadays, the advanced panel are also available. So we can think of maybe 20, 25, 27%. As far as the generation is concerned, if we need to operate the whole power plant, means in terms of, let us say, megawatt, then probably systematic comparison has to be done, whether the photovoltaic panel based the energy has to be produced or maybe from solar system. And that decision has to be taken from the different criteria, maybe from the available place, location, geometry, other resources available, and climatic conditions. And comparing all those situations, we may make a decision whether we should go for photovoltaic based power plant or we should go for the thermal power based technology. In line, in a sentence, it is very difficult to answer that which one is better, which one is having a better efficiency. But I think needs a proper feasibility study, proper assessment based on the location, and then it can be judged that which technology should be preferred. As far as my point is concerned.
Yes, you're right. Thank you, sir. Thank you very much. One more thing, sir. Just it's not a question, sorry. Just I want to ask you that Reliance Industries is going to install. I forgot the figure actually. 1,000 gigawatt. It's they are now planning to install in Gujarat actually.
Adani or Reliance?
Yes, sir. They are planning to install in Gujarat around 1,000 gigawatt or something. I forgot the figure actually. A huge project is going on.
Yes. There are. Oh, okay. Please ask. Please complete.
If they are involving the this like research institute or engineering college like this, that you are the you faculties are very much aware about these technologies and what is called expertise in this field. So if they are involving these local institutions or universities for this, suppose for feasibility study like that, I just want to know actually.
Yes. Very nice. In fact, as far as few industries are concerned in India or in Gujarat,
yes.
We have probably you must be knowing about JEDA, that is an agency which may be a link between industry and a government and a consumer.
Okay.
Same way in Gujarat, we have a separate university, Pandit Dindayal Petroleum University. In that, there is a special sectors also. They are taking help of academician, also floating projects, and many a times they are doing feasibility study. But in fact, it is not happening at the level it should happen like the foreign countries. Through universities, they are taking most of the research project. They developed pilot projects with help of academician, with help of researcher, with help of industry, with help of different industries, and then it is transferred that technology to the appropriate industry. In fact, that is not happening in the India, and I think it will start slowly and slowly. The role of university is going to be very crucial as far as this new technology implementation is concerned. You are very right. It is not happening at the level, maybe 10-20% it is happening, but I think we should increase that particular percentage, and 50-50 percentage means industry 50% and universities 50%. Then that joint project is going to be, as I told you, if you have heard in the discussion in Rajasthan, one of the project was installed in Mathania. This is the reason this project was not successful. It was done without proper feasibility study and proper assessment, I think.
Yes, sir.
If both can, then definitely the results will be better.
Because
very nice.
Yes,
I hope that this will happen in the future.
Yes, sir. Because they're planning. Okay.
Mr. Digant, you can ask your question. You have raised the hand. Diganjit. Okay. Mr. Prasan.
Hello, sir.
Yeah, you are audible. You can raise your question.
Good afternoon, sir. Sir, I saw your PPT, sir. In that, some different coatings you have applied, and you have taken readings on 14th 7 2015, then 17, then 20. So why not a daily basis, sir? Why that 14, 17, 20 like that?
What are the readings you are talking about?
That different coatings you have applied, sir, nano coatings, ZNS, copper, like that, and you have shown the temperatures. So why not possible for 14, 16, 17, 18? You have mentioned 14, 7, 2015, 17, 7, 2015, 27, 2015, like that you have mentioned.
Okay. Few selected readings I have only displayed. I have not taken all the readings. Otherwise, there will be many plots.
Okay.
So the point is that this project was undertaken maybe 5 years back. It was funded by DST, and we attempted to improve the performance of evacuated tube collector, and 3 modifications were suggested. The coating inside the tube, we use internal reflector, and we use the nano fluid in place of simple. And the setup was operated for the whole year, and performance was monitored.
Okay.
Yes. Any more questions?
You can raise your question. You have raised the hand for the questions, Mr. Prasan. You are not audible. Please unmute your mic and raise the question, Mr. Prasan. Okay. Any other participants having a?
I think his voice is not coming. Modi sir, are you there?
Yeah, my voice is audible.
Okay. Yes, Modi sir.
Mr. Prasan, you can raise your question. Please unmute your mic and raise the question. You have raised the hand for the question. I saw. Okay. Any other participants having a query or question? They can raise their query. Okay. So I hope so. No other participants having a query. So we will conclude our session. I thank Professor Bharat and Ramani sir for spare the valuable time and share their views on solar energy, the sustainability. So I thank Professor Ramani for delivering the expert session on solar energy technologies, the way towards the sustainability. Thank you, sir.
Thank you, Dr. Modi. Thank you all participants. And I'm extremely sorry because of online, if there is some connectivity, some audio issue. In fact, this cannot be as much as effective.
Sir, your screen is okay, sir. Now,
Well, thank you. Coordinator for this wonderful workshop and faculty development program. Thank you all. Thank you.
thank you, sir. Okay. Dear participants, so we will conclude the session 1.
Modi sir,
We will meet.
my voice
Yes,
is
sir.
coming.
Yeah, sir. Your voice is coming.
Modi sir, can you hear me?
Yeah, sir. Your voice is audible. Sir, your voice is audible.
Hello.
Yes, sir. Hello. Okay. So, dear participants, we conclude this session 1 at here. We will meet at session 2 at 1:30 p.m. So join via MS Team. The link is already session is already available in calendar. So join via that link only. Okay. So if any query
Thank you,
regarding
Modi
this
sir.
one,
Thank you all participants.
yes, sir. Thank you.
Thank you, sir.
Okay, we will meet at 1:30 p.m. for the second session. Link is already shared. Link is set in MS Team calendar. So join via that MS Team calendar. If any query regarding MS Teams, you can raise any participant.